Have you ever wondered if memory has weight? If you save a file onto a USB drive, does it get heavier? Memory. It's a complex concept that we often take for granted. We store our thoughts, our experiences, our knowledge all in our brain. But when we save a document or a photograph onto a computer or a USB drive, where does it go? And does it add any weight to the device? When we talk about memory in a digital context, we're referring to the storage of data. This data is stored in binary code, a language of ones and zeros that our electronic devices understand. Each one or zero is called a bit, and 8 bits make up a byte. These bytes are the building blocks of all the information stored on your devices, from the simplest text file to the most complex video game. Now here's where things get interesting. There's a common misconception that when you save data onto a device, you're adding something physical to it, thus making it heavier, but that's not quite how it works. When you save a file, what you're actually doing is changing the state of the memory cells in your device. These cells exist in a binary state, meaning they can be either on or off, represented by ones and zeros. When you save a file, you're not adding anything new. You're simply flipping these cells from one state to another. So, does memory have weight? The short answer is no. Saving a file doesn't add any physical matter to your device, so it doesn't increase its weight. But then, how is it possible that something that doesn't tangibly exist can actually exist? This question brings us to the fascinating world of quantum physics and the concept of information theory. It's a realm where particles can exist in two places at once, and where information, even though it doesn't have physical weight, can still have a profound impact on the world. So memory doesn't add weight to a device, but how does something that doesn't tangibly exist actually exist? In the physical world, we're used to things having a tangible presence, but what about intangibles? Do they exist? Let's dive into the world of the intangible, a world that exists beyond the realm of our 5 senses. You can't touch it, you can't see it, but it's there. It's like the air we breathe or the gravity that keeps us grounded. We don't see them, but they indisputably exist. Take love, for instance. We can't touch love, we can't see love, but we certainly feel it. Love exists in the laughter shared between friends, in the comforting silence between a couple, in the gentle touch of a mother. Love is an intangible concept, yet it's a powerful force that shapes our lives. Then there's knowledge. Knowledge is not something you can hold in your hand, yet it exists. It's the understanding of the world around us, the accumulation of facts and theories. It's in the pages of a book, the code of a software, and the mind of a scholar. Knowledge is intangible, yet it's real and it has the power to change the world. Now let's turn our attention to memory. Memory is another intangible concept, yet it's so crucial to our existence. We can't touch our memories, we can't see them, but they're there. They're the stories of our past, the lessons we've learned, the experiences that define us. And in the realm of technology, memory takes on a new form. It's the data stored in a computer or a USB. We can't see this data, we can't touch it, but it's there, holding information, holding knowledge. So, what does this all mean? It means that existence is not limited to the physical, tangible world. There's a whole universe of intangible concepts that exist, that shape our lives, that shape our world. Just because we can't touch or see something doesn't mean it doesn't exist. So how does memory exist in technology if it doesn't have a physical presence? This question might puzzle you, but the answer lies in the fascinating world of science. Think about the device you're using right now. It stores memories, right? Photos, videos, documents, and the like. But where does all this information go? It's not like you're stuffing physical objects into your device. Let's delve into the science behind memory storage. Every bit of data your device stores, from the smallest text file to the most extensive video, is represented by binary code. That's a series of ones and zeros. Now you might be wondering, how can a bunch of numbers carry all this information? Well, it's all about how these numbers are arranged. The key lies in the device's memory cells. In essence, these cells are tiny electronic components that can hold an electrical charge. When we say a cell is storing a 1, it means that cell is charged. Conversely, a 0 means the cell is uncharged. It's like a light switch. When it's on, it represents 1, and when it's off, it represents 0. It's this simple on and off state, charged and uncharged, that forms the basis of all our digital data. The millions, even billions of these tiny memory cells in your device work together to form complex patterns of ones and zeros. These patterns represent everything from your favorite song to the latest app on your device. It's a bit like how the 26 letters of the alphabet can combine in countless ways to form every word and sentence we use. In the same way, the simple binary language of ones and zeros can represent an almost infinite variety of data. So does memory have weight? Not in the traditional sense, but it does exist, in the form of electrical charges in your device's memory cells. It's a testament to the power of science, transforming something as intangible as information into something real and usable. Memory might not have weight, but it has a definite presence in the form of electrical charges. Memory isn't the only scientific concept that seems to defy our understanding. What about quantum entanglement or the nature of light? Quantum entanglement, a term coined by Einstein, is one of those concepts that seems straight out of a science fiction novel. Let's try to unravel it a bit. Picture two particles that have interacted in some way. Now separate these particles by any distance you like. It could be a few inches, or it could be light years. The uncanny thing is, when you measure the state of one particle, you instantly know the state of the other, no matter the distance. They're entangled. This seems to defy our everyday understanding of how information can be transferred. And yet, it's a fundamental aspect of quantum physics, proven time and time again in experiments. Then there's light. We've all heard the question, is light a particle or a wave? Well, the answer is, it's both. This is known as wave-particle duality. Depending on how you measure it, light can exhibit characteristics of either particles or waves. You might think, well, that can't be right. Something can't be two things at once, can it? But in the quantum world, that's exactly what happens. And again, this isn't just theory. It's been proven in countless experiments, like the famous double-slit experiment. These concepts, quantum entanglement and wave-particle duality, are tough to wrap our heads around. They challenge our everyday experiences and intuitive understanding of the world. But that's the fascinating thing about science. It's not always intuitive. It's not always easy to understand. But that doesn't make it any less real or any less amazing. In fact, it's the mystery and the challenge of understanding that makes science so incredibly exciting and rewarding. So the next time you find yourself pondering the weight of memory or the nature of light, remember, you're participating in the grand human tradition of trying to understand our universe. Just because something is hard to understand doesn't mean it's not real. Science is full of fascinating, mind-bending concepts like these. We've delved into the astonishing concept of memory, its weight or lack thereof, and how this intangible entity can be stored, transferred, and accessed. We've marveled at the fact that memory, despite not having a physical weight, can be loaded onto a tiny USB stick, and then retrieved, replayed, and relived, all without adding a single gram to the device. To really grasp this, we need to appreciate the concept of data as a form of energy, not matter. It's a dance of electrons, a ballet of binary, a symphony of signals. This energy can be shaped, harnessed, and directed, but it doesn't have mass. It doesn't weigh anything in the traditional sense, but it does have presence, it does have consequence. We've also explored the existence of intangible concepts. Just because something cannot be seen, touched, or weighed, does not mean it's not real. Thoughts, ideas, memories, these are all intangible, yet they hold immense power. They shape our actions, our beliefs, our very identities. And let's not forget the other scientific concepts that defy easy understanding. Quantum physics, the nature of time, the vastness of the universe, the enigma of dark matter. These are all areas that continue to elude our full comprehension. They remind us that science, like the universe it seeks to understand, is vast, complex, and wonderfully mysterious. But that's the beauty of the scientific journey. It's not about having all the answers, it's about the thrill of the quest, the joy of discovery, the awe of the unknown. It's about pushing boundaries, challenging assumptions, and forever seeking to understand just a little bit more about the incredible universe we inhabit. The world of science is a world of wonder, full of concepts that challenge our understanding and make us see the world in new ways.